All right. Good morning. Welcome back to Applications of Calculus 2. We are dealing with integration by parts. And when I'm looking at a problem like this, you know how I know it's going to be integration by parts? There's a logarithm in it and there's no fraction. If I want to do a u of let u equal something like ln, my du is going to have to be a 1 over something. So we don't have that. That's why I know this is going to be integration by parts, because the only way to integrate logarithms is integration by parts. Now, I set up my logarithm, or I set up my integration by parts in a particular way. I say, okay, let u equal, and then I look at these, I'm like, which one is going to be easier to take a derivative? Which one of these is going to be easier to take an integral of? Well, I can't integrate natural log without integration by parts. So I'm, not really fond of wanting to take the integral of natural log. So the first thing I'm going to look is like, I would rather take the derivative of this. You can guess wrong. It is possible to guess wrong on this. And you say, well, maybe I screwed up and I got to change them and redo it. Like that happens. And if that does happen, like you were one of thousands of people that this happens to. Don't feel bad about that. It happens to everybody. So the other thing about doing integration by parts is all the pieces kind of have to get used up in your integration by parts. Like think about a chemical reaction. Like they all have to get used up to get you your result. So we're going to say, okay, let u is equal to, we're going to say ln of 4x. du is equal to, okay, just take the derivative of a natural log 4x. We get 1 over 4x, 1 over 4x times 4, which is still just 1 over x. Okay, let's put that off to the side here. My dv is equal to what's left. It's 3x minus 2 dx. Okay, so now we've accounted for each and every one of these pieces got used up in the u and the dv setup of integration by parts. My v, we're just going to go through and integrate this. This is just going to be 3 halves x squared minus 2x, right? Now, when we put it together, you just make a little, we've made a little box, and all we do is you multiply the two diagonals together. So it's uv, so we have 3 halves x squared minus 2x times the natural log of 4x. Notice I put the polynomial before the logarithm. It's not like a rule that you have to do it this way. It's just that it tends to work better because when people are reading this quickly, if you have the polynomial afterwards, they might make the mistake of thinking it's the logarithm of this whole thing. So we try to put the products of natural logs. We try to put like the thing that's not in the natural log first, so we can not make that mistake. Minus the integral, and I've got 3 halves x squared minus 2x times 1 over x. And we're going to go ahead and, this should be a dx here. We're going to go ahead and, in fact, simplify this piece. This is the key of this, what we're trying. This is what integration by parts lets us do. So we have 3 halves x squared minus 2x, parentheses, natural log 4x, parentheses, minus, and then we're going to integrate. Now I've got to deal with this 1 over x. So this is going to be 3 halves x squared over x is just going to be x, minus 2x over x is just going to be 2. One of these x's canceled for both of these terms. We still have to integrate this. So we're not quite done yet, but we're getting close. Okay, so we still have our 3 halves x squared minus our 2x, parentheses, natural log 4x, minus. Now it's time to integrate this piece here. So this is going to be 3 over 2 times 2 is 4x squared. It would be x squared over 2, but I've taken into account for the 2 over here. Minus 2x, but let's put parentheses here because that minus is going to turn into a plus. Be careful. And then when we're about done, we're going to give it our plus c, and we'll go ahead and deal with that. So just to clean this up, just one more line here because I didn't write it the other way. Let's see here. Sure we have this going on. Okay, there we go. Okay, my comically large eraser here. Here we go. Natural log of 4x minus a 3/4 x squared minus a positive is a plus 2x plus c. And that's the way you want to kind of do this integral. So with integration by parts, the setup is key. Like I said, I always try to do it by u. So every time I do a integration by parts, I pick a u and a dv. We have our du and our v, and I know my formula is just going to be uv minus v du, and I don't really think about like trying to memorize the formula, if I set it up with this particular shape, because I've done the shape and I know that the pattern, what the pattern is, I don't have to worry so much about what the formula is. I can just say, okay, I know that this setup implicitly gives me the formula, and I don't really have to worry about trying to memorize that. So it also keeps me from trying to integrate the two of them like as a product. You don't want to do like you don't want to set an integral up where you're integrating this one and integrating that. Like that's not going to work. So be careful about that. You want to set it up in a nice way, get your integration by parts all sorted out, and then there's going to be your answer. So thank you very much for watching the video. Good luck with everything, and I will see you in the next video.